Matt Kramer here, and today we're going over using a MicroSquirt to control a Toyota A340E automatic transmission and the similar A341E. Those show up in the Supra Turbo and a lot of your rear-wheel drive Lexuses, trucks, and some other things. They also show up in the Jeep as the AW4, but those have different wiring, and I'm not going to cover that here. The AW340 family is pretty straightforward for the most part, but it's different from a lot of the other 4-speed automatics out there. Since the MicroSquirt's automatic electronics happen to be a bit easier to use with other 4-speed automatics, then there's a few things that get a little more complicated with using MicroSquirt here compared to something like a 4L80. One of the biggest differences on the A340 is the shifter input. A lot of your other transmissions find a way to get the gear position into binary code, so you could pack 8 possible shifter positions into 3 wires. Toyota just used 1 wire for each of the 6 shifter positions, plus the overdrive cancel switch. So you've got 7 shifter signal wires, and there's 4 shifter position inputs available in the MicroSquirt. Toyota's wiring is great for shifter position lights, not so great for your microcontroller. The manual calls for a multiplex circuit to solve this. It takes 7 signals and creates a unique output for each signal using these diodes and transistors on the left. It also brings in 12-volt inputs, and these circuits on the right drop them down to 5 volts to fit the MicroSquirt's input. You can lay this out on a breadboard, or I've teamed up with David Buckshaw. He's got some pretty infamous 2 JZ projects out there to offer these ready-made. Let's take a closer look at the diode's logic. The park wire just turns on selector B. Move to reverse and you get both A and B on. Neutral goes back to just B. The transmission controller doesn't have to do anything different from neutral and park, so they just look the same. Now if you go to low, you get A, but not B. Second isn't connected to the circuit at all. So if you don't get any shifter signals, that tells the MicroSquirt you have the shifter in second. If you put the shifter in drive, you just get a signal on selector C. The transistor here keeps the overdrive cancel button from sending a signal unless you're in drive. If you are, then you get a signal on both B and C, and that tells the MicroSquirt it can go up to 3rd gear only. Now we've got the shifter solenoids, and they're also a little different. You have 2 shift solenoids, 4 forward speeds, so there's 4 possible combinations of on and off, 1 for each gear. That's like a lot of other 4-speed automatics. The main twist here is that they have one end grounded to the transmission case, so you've got to send them 12 volts, while the MicroSquirt expects ground. You can use one of the HSD4s from DIY AutoTune here, or a pair of solid-state relays. The early 2000s Jeep Grand Cherokee used one for their cooling fan, so you could grab a pair of those at your local parts store, although they are sometimes called cooling fan control modules instead of cooling fan solid-state relays. Now, depending on the transmission, we have 2 or 3 other solenoids, and for some reason Toyota wired both their 12-volt and ground side to the control unit. I've got no idea why they did this, but that means you can just wire one side to your 12-volt supply and the other side to the MicroSquirt output, and you don't need a solid-state relay for those. Toyota calls one of these SLU. This is your torque converter lockup. Some are on-off and some are PWM. You'll have to look up the service information for what your transmission came out of. The MicroSquirt has settings for both types. I'm going to say when in doubt, set it to on-off. This might be a little bit harsher when it kicks in, but I wouldn't want to use PWM if the transmission's not meant for it. Then you have the SLT solenoid. No idea what that stands for, but it's your line pressure control solenoid. This is always PWM control. Leave it off, you get full line pressure. More duty cycle lowers the line pressure, makes your shift a bit softer, but it's kind of like riding the clutch. You get more wear and tear on the transmission that way in order to get a softer engagement. The MicroSquirt's PWM control for the line pressure solenoid is backwards. It's not showing you duty cycle, it's showing you pressure. So 100% is going to be full pressure. The last one's a bit of a weird one. It's called the SLN solenoid, or accumulator backfill. While the SLT solenoid sets the pressure that pushes on the actuators, SLN regulates the pressure that pushes back. That's the best way I can explain it without really getting into the weeds about their internal hydraulics. It works in the opposite way of the SLT. Gives you minimum pressure when it's off and maximum pressure at 100% duty cycle. But since this pressure is pushing back against your usual line pressure, lower pressure makes for firmer shifts. Most aggressive shifting is going to happen if you set to 0 duty cycle on both SLT and SLN. Don't know why Toyota decided they needed 2 tuning tools for the shift pressure, but that's what we have. And incidentally, the default does have a fairly high duty cycle on SLN. It's not going to ride the clutch as much as a high duty cycle on the SLT solenoid. So if you're building a project around a 2JZ or 1UZ with an automatic, and you don't want to use the stock electronics, they're not very tunable, can't blame you there, and you don't want to swap to an 8-speed transmission and its electronics, this is one way to get yourself a standalone transmission controller.